Hello, fellow Christmas light DIYers. This is Rees. I'm going to show a little bit what I've been working on with the mini hanging lights. The kind of idea is maybe some of those who have done lights on the outside. This is an option for indoors, or those who maybe don't have fancy yards or large yards or property. Maybe an apartment. This could be an idea that you can hang in your window, little suction cup things. You can hang some lights and then use one of those ultrasonic speakers that turn your window into a speaker. I mean, you could get really creative with it, but you could create a light show in your house, in your window, apartment window, or maybe something in a mall setting with a tree with animated lights. So anyhow, this is kind of the project I've been working on for the past year. I actually have a couple boards left that I need to pick in place. As you can see here, I've got the PCB board that I designed, and then these take the WS28 2812B 2020s, really small LEDs, and I have a solder mask that basically goes on top of that board, and I put the solder on it through that mask, and then use tweezers and a little bit of patience and place each of those LEDs in the correct orientation so it's not backwards. And then when it's ready, I stick it in this oven. I have basically I create little solder blobs on the board, and then I have a timer, and I set my temperature to a couple minutes to kind of get the temperature warm. You want to ramp up slowly. And then basically then I turn up high, and then when the solder balls or little blobs turn to solder balls, I know I've hit reflow, and I basically count to 10-15 seconds to give enough time for the whole board to reflow. Reflow is the act of solder paste turning into molten solder, and then all the parts kind of suck into place. If you're unlucky, you'll have some parts that will kind of not sit properly. Fortunately, I've been able to do 100% success rate without having to manually fix any of the LEDs. So done right, and the key is a good solder mask and having it exact on those pads. You'll have a pretty high success rate. Not for everyone, granted. Yes, you're gonna have a steady hand and some tweezers and some patience. If that's you, this is your thing. If it's not you, I hope to have some finished boards that can be purchased. I got to figure out what's going to make it worth the time. Obviously, people are going to have it. There might be some bad LEDs. How am I going to approach in either providing support or allowing them to figure out a way to fix it themselves or provide a repair service? There's a lot of responsibility if I'm going to go that route, or hopefully the DIY community can provide an infrastructure, and if there's enough interest to support each other in such a fun new way to do this hobby. So these are the boards. One thing that's important, anything that you have hanging on a tree, we all know that if you go and touch it, it's going to have static discharge. If there's anything in this world that will destroy LEDs, especially these small ones, is static. So I got a little creative. I did create basically it's just a really thin PCB. I think it was 0.6. Of course, I'm holding my phone and I can't get this out. Let's try this here really quick. All right, got it. I'm sure you guys wanted to wait for that. So here is the top board. It's really just a PCB 0.6 millimeter thickness, and it's got places for the post to be soldered to. So these are just, I can't remember what millimeter size screw, but nonetheless, the screws are, and those are grounded screw pads, so that these screw marks are grounded, at least, or especially this one. And that goes to a cap that basically absorbs the static energy and then drains it to ground, and that goes through a little via and creates this nice little rim. So if you happen to touch it, which I have actually intentionally and unintentionally tested this static discharge, and walking up to this and handling this, it will efficiently drain all the static energy out of your body into that ring, into that buffer cap there, and that cap goes to the post, which is ground, which is soldered right onto the ground of these guys, and that's it. So this is a 5-volt board. Now, some of the things I got to work on. This board can consume a lot of power. This is a problem with the WS2812 LEDs, and yes, there could be some fancy engineering into heat dissipation and making sure heat gets where it needs to go. However, these LEDs, even at 5% on my FPP settings, is actually comfortably viewable. 15% without this shield is blinding. Any higher than that is just unreasonably too bright. Now, that's good to have a lower setting. Now, you lose some color ranges and accuracies when you do that, and we all know that when we drop our current. So there's some options here, and I'm looking at exploring those, possibly using the low current WS2812-2020, which will give us a little more range. However, to do that, I have to put caps next to each of these, which would be a board redesign, and would be a board redesign, and I need a little more space for those caps, but it can be done. So that's that route. Or we look at maximizing the 15-20% brightness setting and just using the right settings to get the color range that we want. And using, what I'm going to add is a E-fuse to the board. And what that does is, in the case that either your settings intentionally or unintentionally are set too high, I want the fuse to trip to prevent this board from getting too hot. I guess that's the whole dance for the past 2 minutes of explaining what I'm trying to lead up to here. They get too hot. Not only too bright, but too hot. That could be fire hazard, possibly. Melting stuff you don't want to melt, and burn the little kids' fingers when they touch it, and we don't want that. We don't probably want them touching it anyways, but that's what the shield here is, to help protect us and ensure us against static discharge. Nonetheless, as it sits, yes, as a DIY and for myself, I feel I'm responsible for what I do. I'm owning it. But to sell this or to provide this to the DIY community would be a disservice if I don't provide some measures into protecting not only your investment, but also preventing it from overheating. I'm trying to think how many amps, and I'm gonna have to go back and put it on my workbench power meter and all that. But the low setting, the 10-50% power setting, running it, it's warm to the touch. It's great. It's not too hot. But if it's above 50% for duration of time, it's very hot to the touch. I wouldn't say scalding, burn your finger blister hot, but it is very hot. So anyhow, that's that. So let's go and look at it in action. Okay, so I'm gonna go ahead and push play on this, and we're gonna let it play here. Now this is I'm using these nice handy boards. They're little pie hats. And anyhow, I'll provide a link in the description, but it's the microcyb.com by Darren. Great guy, makes awesome boards. Highly recommended. Pi Zero. That's what I have the lights connected to. 1 bulb per port. And I think it's like a 3 or 4 amp 5-volt power supply that I have going into the main. So let's go take a look at that as it's playing right now in the background. All right. So here we go. So what I got the LED display there hanging on the tree. Try to get a focus there. You can see right there the side of the board. Pretty cool. All right, so we have just kind of nestled in there. Yes, it should be an enclosure. I just have it sitting on a branch, running at least one of the bulbs right there. Got the other one. This is the miniature one here. That guy right there running it. So, and this is 5% brightness, guys. Even with the lights on, it's still bright enough. So what I've done that's creative is I got this USB connected to the Pi Zero. It's got an Ethernet port on it, so if I want to connect this to Ethernet, I can. But I got a USB audio speaker, which is basically a speaker with a little sound blaster built into it, so it detects as an audio card. So So yes, what you're hearing is being played on that little USB speaker at the base of the tree. So we can make this interactive. You could get a Raspberry Pi and have it do some AI detection, have the dog walk by, and then these singing light bulbs can do who let the dogs out. Some really crazy cool things you could do with this kind of direction that I'm dreaming of, if you will. Do the build up here. Jingle a bell, jingle all the way. Whatever made is the ride on the Mongolian sleigh. Jingle a bell. Basically have the lights broken up into 3 sections: the top, the bulb, and then the singing face. You got this little effect that makes it look like he's kind of doing a little cowboy dance there. And that was clear. There we are. Clear it up. But that's it. Singing light bulbs. So kind of a crazy new way to do things. And is it for everyone? Nah. Is it for people who like to tinker, the DIYers? Absolutely. Another project we're working on is these plug-in light controllers. And some of you may have seen my post where basically I'm using I think it's $23 PoE camera switch. Now, I'm a network engineer by trade, so I'm not advocating going for the cheapest thing. But I do identify pieces of equipment that do small, simple tasks. In this case, if I need some cameras, I need a hookup. And there's various options out there. Yes, a lot of them are cheap and some of them are great. This one is kind of the cheap, great option. What's good about it is I could get around 90 watts of power out of that switch to run my displays. And the cool thing about it is you'll notice here, there is no Meanwell power supply. I got this adapter and a board that I'm working on that's in that enclosure. Now, this isn't Mattles Design sponsored. I liked his stickers I got from his lights, so I threw one on. So yes, that's not official. Mr. Mattles, sorry, I didn't approve that. You didn't see that. But anyhow, nonetheless, I like a sticker, so I stuck it on. But these are, I call them plug-in light controllers. Basically, it is that. You plug it in, and they light. Very little power supply engineering. It's more plug and play. And the idea is that we could stick one of those on the back of a flake, and you can click it into your PoE switch in an enclosure, and you're up and running. Is it cheaper? No. Is it cooler? Absolutely. Is it for everyone? No. So anyhow, just some stuff that we're working on.